Hi, this is Jason Gossett again. I'm going to be doing the Interactive Advanced Concept Presentation 2 for Module 2 of Week 2. So this is basically creating our homemade lava lamp to show some chemical reactions between different products. So I've got some water already in here and some house cooking oil. So we'll put this oil in the bottle real quick. Actually, I'll do it over the sink just in case it spills. And as expected, the oil and the water don't mix. So just like you'd see with a salad dressing, or trying to think of any, like you see car oil and any other oil doesn't really mix with water. There's two reasons. First, the water's more dense and the oil is less dense than the water, so therefore it's going to sit on top of that water, and they are separated. Second thing is, I remember from my biology class I took last semester, the water itself is a polar molecule, and oil is a nonpolar molecule. So the two don't attract to each other. So polar molecules are going to attract to other polar molecules, whereas nonpolar to other nonpolar. So therefore, that kind of creates that separation as well. They don't attract to each other. So before I put the Alka-Seltzer tablet, I'll put just a couple drops of food coloring. We got some blue food coloring in there. And hopefully that should be enough. Apologize, I tried to get the labels off this bottle and it actually made it look worse, so I just went ahead and left them on there. So here we've got some Alka-Seltzer. It's already kind of breaking apart a little bit. And we'll drop it in and see what it does. Give it a minute. So you can see it's starting to create bubbles. And the reason with that is Alka-Seltzer, when it reacts with water, it creates carbon dioxide. And that carbon dioxide gas is going to rise. So what it's doing, and the food coloring kind of helps show it, so the food coloring kind of went down to the bottom with the water. Well, as you can see, the bubbles have that blue food coloring with it. So basically what's happening is this Alka-Seltzer is creating that carbon dioxide gas, which is then rising both through the water and then through the oil, which are separated. And when the carbon dioxide leaves the water into the oil, it kind of grabs a little bit of that water with it, and then it basically, once it gets to the top, it's going to bust or pop the bubble, and that water will then go back down to the bottom, to the water at the bottom of the glass, because again, it's more dense and it's polar and not going to be attracted to that oil. And we can see it's starting to slow down. Well, actually, another one just kind of kicked in, one of those Alka-Seltzer tablets. But the reason it's going to stop is because the Alka-Seltzer runs out and that carbon dioxide gas is no longer produced. So if you think about it chemically, the water is the reactant. I mean, the Alka-Seltzer is, you can think of the water and the Alka-Seltzer as reactants producing that carbon dioxide gas when they mix together. And that is the product of what happens with those bubbles. So that's kind of a short explanation of what's happening there. Obviously, we could add more Alka-Seltzer tablets and create more of that carbon dioxide gas to continue and keep it going, which would be a fun experiment with young kids to kind of show them how you could build a lava lamp yourself, and something cool to kind of teach them a chemical reaction as well. But that is it in a nutshell, and I appreciate it. Thanks.